Hey, all right, so this is the fifth screencast of my differential equations class, and it is over Laplace transformations. And so the problem we are solving is find the Laplace transformation for the form for the following, which is first we take note that this is a piecewise function. So we're gonna first start with, we have the definition of a Laplace transform, which we get from the summation power series, but make it continuous. And so we have this right here, so it's some function times e to the negative st. That's going to give us some function. So since we have two, we're going to set this up as the integral from 0 to 3 from over here, with this times 0, which is the function, plus the integral from 3 to infinity of e to the negative st, t minus 3 dt. So the first thing we need to realize is that this first part right here, it's a proper integral, but it really doesn't matter because it's times 0, so it's just going to be 0 anyway. So the one we care about is the second one, right? But this one, unfortunately, is an improper integral, so we have to treat it, basically have to rewrite it as the limit from n to infinity of the integral from 3 to n, basically everything right here. And so to integrate this, we need to solve it by integration by parts, which I've done right over here. Right. And so basically we're going to do this and we're going to set this up. So limit n to the infinity, carry that down, can't forget it, and do this, e to the negative st over s times t to the negative 3 minus this, and just mostly make sure to keep your signs all correct. And you're going to evaluate this from 3 to n. So which I've done over here, right? And I've written it all out. But then what happens is this first term from when you're evaluating it by 3, it's just going to become 0. So you just can get rid of it. And so then what you get is this part, the first part, which is the negative, this right here. And we basically, because this is an improper integral, we know that there's going to be some stipulation on s for to qualify your function that you're going to get at the end. And so to do this, we want this part to be 0. And when this is going to be 0 is when s is greater than 0. So when s is positive. And then, so then we're left with this last piece over here from before when we took out the other part that was just going to be 0. And so that's negative e to the negative s times 3 over s squared times 3 again. And so since we know that this is kind of what our function is going to be, we are going to bring it over here. And so you're going to, because we can't forget about the 0 from the very beginning. And so we have limit n to the infinity equals 0, which is from here, minus 0 minus this right here, right? Because we're assuming this is 0 because we put the stipulation that s is going to be positive. And so from here, we can then distribute this 3 internally, and then we get that the answer, because there's an improper integral, we have to include the limit n to infinity is negative 3 e to negative 3s over s squared, only when s is greater than 0. And so just for clarification and everything, I included a picture of the function that we were originally graphing. And this makes sense. This helps makes this make sense because there is when you differentiate for differential equation, there is no area underneath this line from t is 0 to 3. There is no area, so that makes sense. This just becomes 0. And then, this right over here from 3 to infinity, we have this increasing area. So that makes, and it's going to go to infinity, right? So that's why you need to take the limit versus getting an actual, just for when it can't exist for everything. And so, and it's never going to be less than 0. S is never going to be less than 0 because it's increasing. And so, yes, I hope that everyone had a really great Halloween, and gonna peace out.